Good morning, everyone, and welcome to day 2 of Digital Building Week. I'm Holly Ty, Specification Editor at Assemble Media Group, and today I'm joined by Graham Brady, Engineering Manager at NG Bailey, Tim Carey, Design and C2P Director at Mace, Dave Clough, Director and Head of MMC at Turner & Townsend, and Helen Huff, Head of Building Physics and Sustainability at Bryden Wood. And today we're going to be exploring prefabrication and design for manufacturing assembly and how these methodologies offer solutions to the challenges faced by the sector today. There will be time at the end for a Q&A, so please do send in any questions you have. And without taking up any more of your time, I'm going to pass over to our first speaker, which is Tim.
Thanks a lot. I'll just share my screen. Into my screen. Okay, thanks a lot. So as Holly said, my name's Tim Carey. I'm Design and C2P Director for Mace. Our brand strapline is to redefine the boundaries of ambition, and that nowhere more is that relevant than what we choose to do in terms of innovation. Our most recent innovation strategy a couple of years ago was called Speed and Scale, and really that was trying to capture our approach to prefabrication and off-site, which we've been doing for over 20 years. And really, we call it construction to production for reasons that I'll go on to a bit later. But it gives us the ability to achieve efficient, high-quality, right first-time construction by not just doing, by running processes in parallel. We manufacture off-site whilst building on-site as well. And really, that strategy's got 4 cornerstones on it. So construction to production, so what we do in terms of pre-manufactured off-site things, but really for me the benefits of DfMA and standardization are when you also link it to net zero carbon, digital and data, and now circular economy as well. We're solution agnostic, so we don't specifically own a factory, so the answer is not always what the factory produces, but what we do is we partner closely with manufacturers and help them to develop their technologies that sit across all of the MMC definition frameworks. That also means that we can benefit from really an integrated model. So if we put people together, we've also got a scalable model where multiple manufacturers can often make similar components as well. So we're not limited by the fixed overheads of a manufacturing facility or the actual capacity in and of itself. And I'll show a few examples that go across this framework. But what we do is make sure that we've got a big emphasis on how we capture the metrics that sit around the use of MMC. Anecdotally, we all, I think, believe that doing things in a more manufactured approach is better than doing things traditionally, but it's often hard to find the evidence that supports that. So for a start, any C2P solution that we do, we make sure that we fully explore, we develop, and we thoroughly test it. And for that, we've appropriated NASA's technology readiness levels that measure the maturity and readiness of each of our solutions. So whether it's just from a good idea, proof of concept, business case, trial it in a factory, trial it as part of a site, trial it on a whole site, etc., all the way through to deployment. We track that all the way through and measure, validate, and verify the benefits as we go. And then ultimately each solution then becomes ideally superseded by the next iterative version of what it does before it's fundamentally withdrawn. This is a screen grab from a CAST document, but for me, PMV was on one of the previous slides, but PMV is an input value. What we need to do is to correlate, as these graphs show, the input of PMV versus the outturn costs. Ultimately, we do something because we want something else to happen. Whether that's improved time, cost, quality, etc. And I like to think that, every project has got a center of gravity. If we try and map on the benefits or the various benefits that are specific to a project, we will find a kind of spider map and we will find a center of gravity. And that won't always be the same on every single project. So for example, if you took housing or multi-occupancy housing, there will be certain types of sectors within that. So, for example, affordable rent, or or private rent, where as many units as you can hand over as quickly as possible is exactly what you're looking for, and therefore something like a volumetric modular that will drive that speed will have benefits. Conversely, if it's private sale and your sales rates are not sufficient to do that, you're going to end up with a load of empty units that are ready to be occupied but can't be sold. So in that context, the same type of job but different centre of gravity. And when we're looking at each individual solution from a C2P point of view, it's kind of, well, where's the centre of gravity for that solution and how closely does it map onto the project? Is going to be a good indicator of which solutions to use. We've got as I said, we've got quite a long track record in the use of MMC off-site solutions. So whether it's something like the Rising Factory that we used in East Village in London to undertake works in a controlled environment on site, all the way through to our high-rise solution, which is an evolution of what I just showed. This is a job at Chapter London Bridge. Here, the two photos in the middle and on the right-hand side show the progress 12 months apart. And it's a good example of DfMA. So it's got 4 or 5 key components: Omnia planks, reinforcement, precast cores, pre-manufactured cladding panels that all come together and attract through RFID tags from cradle or from the factory gates to the installation. We've also developed things like low carbon cassettes as part of an Innovate UK funding that have got estimated benefits. I use the term estimated, so reduce the weight of the frame, reduce structural steel, etc., etc. What's key is, well, what are the benefits that actually outturn? Can we capture those? So we do capture that on every single project. So, for example, we've used that solution on a job called Palmerston Court. We put 127 low carbon cassettes in there, saved nearly 7,000 people hours on site there, which has also got a health and safety perspective, knocked 8 weeks off the critical path and saved 152 tonnes of carbon, which is a 40% reduction. And also delivered that scheme, or are delivering that scheme, to the Passive House standard. So it goes to show you can drive really high performing buildings with, with MMC as well. Other technologies, so a Cat 7, Dave the Dog, I think it is, by Boston Dynamics, using that to undertake works that would otherwise be manual in terms of laser scanning, and a whole load of pre-manufactured plant and equipment, both modular and vertical risers as well. So doing whatever we can do in the most appropriate controlled situations. I mentioned that we do track benefits and analysis. So every C2P solution has one or more data sheets for every time it's deployed that tracks its technology readiness level, key consideration, and then we metricize 7 key benefits, similar to the spider diagram that I showed earlier, so that we can make sure that we are incrementally learning and refining each of those. That then enables us to track through, using things like Uniclass numbering system, all of the benefits holistically on all of the projects that we do, whether it's site hours saved, embodied carbon, or program. So really being able to then dive into, understand the solutions, and then take it through. So building smart, if we go back to the definition of smart, specific and measurable and achievable, we like to think that we are doing that. Most important is how we share the love and how we share the knowledge. So we've now launched within MACE a C2P digital library, where all of our data sheets, all of our decision matrices for understanding a project and choosing the right solutions can all be accessible by everybody. I'm conscious I've only got 8 minutes, so that is a real whistle-stop tour through, but I'm happy to take questions afterwards. Thank you.
Thank you very much, Tim. I'm going to pass over to Helen next.
Great, thank you. Great. So yeah, I'm Helen Hoff, Head of Sustainability at Bridon Wood. So designers, architects, engineers, and so on. And I'm going to talk mostly about the platform approach to DfMA. So the idea is that we are taking lessons from the manufacturing sector and applying them to construction. So platforms they're based on the understanding that a comparable built asset can have many common characteristics. So that could be things like the floor-to-floor height or connecting horizontal and vertical structural elements and so on. So in a similar way to a flat pack furniture, we get a standardized kit of parts that can be created using really standard elements that can create customized buildings. So this here is a prototype which was developed alongside both government and private partners to test the platform approach to DfMA. And everything is really simple to install, and it takes on quite a lean design approach, and that has a massive array of sustainability benefits. So I'm going to talk a little bit about lean design, circular economy, adaptability, but there's obviously a massive array of other sustainability impacts, such as program efficiency, well-being, energy efficiency, social impacts, that kind of thing, that I just don't have time to talk about, but obviously happy to answer questions if there's something that is of particular interest. So I think everything that undermines it is having a lean design. So we want to reduce the amount of materials. If we reduce the amount of materials, we'll have hopefully a smaller building, less operational carbon, so less building to heat, and then less embodied carbon. So, I mean, in this example here, we've got a highly optimized superstructure, which goes back to the image that I showed earlier, where if you can reduce your material quantity, then you'll have fewer transport movements, less waste, less embodied carbon, and the sort of chain reaction keeps on growing. If you then look at the impact of the superstructure on the substructure, if we have a reduced material quantity, we've got a reduced building weight. That means we've got smaller foundations, less material, less embodied carbon. And actually you can take that approach across your whole building and the chain reaction is huge. And if we could do that for every building, just think what the impact could be across the country. So I'm going to talk a little bit about the Forge, which is a project that was completed last year. It's two 10-storey office buildings in central London, just behind the Tate. It's the first net zero carbon office in the UK, as endorsed by the UK GBC. So it just shows that the use of DfMA and the platform solution doesn't prevent sustainability or sustainable buildings, but actually helps to enhance them. So in this example, we have DfMA in use on the facade, structure, and the MEP services. And I think Graham might be picking up on the MEP a bit later on as well. So in terms of embodied carbon, we're in a really fortunate position where the business as usual case was designed to read the stage 3 as a traditional construction. So by doing this, we've got a really good baseline, and we can see the direct impact that DfMA and some of the other design decisions have on the embodied carbon, and we got to a 39% reduction. And you can see that most of that is actually in the superstructure, which is this yellow section on this bar chart. And the idea of having a platform approach that follows that lean design reduced our material quantity so significantly that there's a really significant saving there. And then that also has an impact on the basement, or the lack of basement, and the substructure. We've also found that the use of DfMA and the amount of control and understanding that you have over different components throughout the whole design and construction stage means that you can start to reduce material quantities, waste, and also enables more self-finishing of materials, so you don't get that extra layer. So, for example, the curtain walling on the internal prevents the need for additional internal finishes. And all of this goes back to that lean design decision making. In terms of circular economy, the idea of having DfMA means that we need to have so much more knowledge and understanding over the building that we're designing. So you can take the whole of the life cycle into account. So right from the early product stages, where you're thinking about what materials you're using, how you're going to build it on site, how it will be used, what happens at the end of its life, thinking about those deconstruction or deconstructability scenarios and building those in the design stage. And then thinking about what happens on the next building. Well, if we know we've got standardized components, we could deconstruct those and use them on the next building, which would also be designed to use the same components. And that only really works if you build in layers. So you think about what part of your building will have a longer lifespan. And I think because we're designing so much better quality from the outset, we've got more control, and therefore it's more easy to support circular economy principles. In terms of, sort of adaptability and future resilience, the idea of having DfMA on the superstructure can, if it's followed through onto the facade as well, you can respond really quickly to changes in maybe future building uses. So we've seen a massive change in the way that offices are used throughout COVID, for example, all the way through to knowing that the climate is going to change in the future. So if we have facades that are deconstructible, so have bolted connections, they've got mechanically fixed external fins, for example, we can swap and change those depending on what people need. So if you have an occupied room that suddenly is along the facade, you can switch out your windows for an opaque panel and reduce your energy consumption. And that would also work the other way around. So actually you can prioritise people's well-being, thermal comfort alongside the operational energy and carbon, allow a building to last longer, which has a reduced whole life carbon. And finally, flexibility and adaptability. So the idea of wanting to allow a building to evolve over time to suit how people are using it. So having a strip grid, so in this case it was a 9 by 9 metre grid, which could be separated into 3 by 3 metre, and then the facade goes down into 1.5 metre. And it will allow the provision of internal walls, partitioning with minimal impact to the internal services and the external facade. And that allows us then to balance over-designing with the need for flexibility. And I think it then goes all the way back to where I started, saying about lean design and not wanting to over-design, just reducing oil material quantities, use DfMA with the knowledge that you have to create more sustainable assets.
Thank you very much. I'm going to pass to Graham next.
Thank you very much. I'm Graham Brady, Engineering Manager for NG Bailey Offsite Manufacture. I'm going to take you through a journey of where we've been from over the last 20 years, from where we started to our kit of parts and standardisation approach. So back in 2000, we were manufacturing 4-pipe fan coil units from an MEP perspective. And these were very rigid in their design and construction. So we had a set grid that we applied it to, and basically we made the services fit the modular construction to allow us to complete a floor for an office block. As we developed through the time, obviously we wanted to expand our product range and developed a process that allowed us more flexibility, to the point where we were building nodes at T5 and risers up through T5. Birmingham New Street, where we did a 110 metre spine through the middle of a live station, all very bespoke, all takes a lot of engineering. And in the latter 4 or 5 years, we've been developing more standardised approach, looking at the Nightingales and the Forge, as Helen mentioned, where we were looking at kit parts and developing that. But the process was key. So the process we used to adopt was, we came up with a concept, so we'd look at the building layouts and we'd identify in very early stages where we've got risers, plant rooms, horizontal distribution, and what systems we could use. Then we were going through a feasibility, so can we actually deliver the product we want to site? Is it wide? How wide is it? How long is it? How heavy is it? How are we going to lift it in on site? To come out with a feasible design, which then goes into detailed design through Revit, And we've developed various systems within Revit to make that as efficient as possible, and also do design checks as we're going along, and then into manufacture, and obviously after to site and delivery. So where we've got to with the kit of parts approach is we can call on the standardized kit of parts catalog within Revit and basically pull those into the model as we're developing the solutions. And basically it misses out that concept and feasibility step, and gets to us a standardized design that suits the project, and then we're straight into manufacture with already developed operating systems and the drawings already complete. So here's some examples. So I've just picked out a few that we're going to use in some case studies further on. So we've got some valve set modules, some pipework modules, and fan cleaning modules. But the other ones you see around are standard brackets, distribution boards, or plant skids. So on MECD, so a university project in Manchester, we looked at the original design, and there was a significant number of rooms, chill beams, and right out at the outset, we decided we were going to standardise and develop a standard valve set module so that it could be used throughout the whole project. So we developed 8 types of valve set modules. These were inbuilt within Revit, so basically the BIM coordinators could pick the valve set that they needed, and then place that in the location in the building where it was required, and then progress on with the design. So they could be focused on the areas outside of that valve set, just taking that standard design. From a manufacturing point of view, we were then able to kit the parts up, develop those with standard cut lengths. So in the valve set that you see there, probably had 3 different pieces, 3 different lengths of pipe. So we were able to use Kanban systems to make those as efficient as possible, and also the testing. And then we had a standard delivery method and a standard installation method. So making the most efficiency all the way through the process, right from design all the way to installation. And obviously going forward, what Manchester University are left with is every single valve set, 8 types of them, all the same with the same components. So from a maintenance point of view, a real benefit. Helen's sort of described the forge already. So the vision of the forge was to come up with the kit of parts approach, a bit like the car industry, so that the kit of parts could be used on not just the forge, but multiple buildings going forwards in the future, generating that efficiency from a design and installation perspective. So what we came up with was fan cleaning modules, pipework modules, conflow modules, which housed the sprinkler system, did some architectural features and acoustics, and also the containment and modular wiring, and then some lighting modules off the back of it. In total, we made 4,500 components over the 16 floors that Helen described earlier. And what we were all able to optimize was the installation method. So not only from a design perspective, we made efficiencies. Obviously, during manufacture, we were making multiple components, as you see, that were the same, generating efficiency there. But we came up with a standard installation procedure that we only touched each module a single time. So you can see we had a jig under the electric lifter. We lifted the modules up, fixed the first the top module, and then lowered the other stack and moved on to the next one. Because of the way Bridon Wood and Mace developed the design, and the shuttering system, we were able to have predetermined half-and channels within the concrete structure, which allowed us to eliminate 95% of drilling within the project. So we had health fins fixed in there, and basically a unistruct grid that all our modules fixed into. So really efficient installation. So taking a typical fan coil unit, so typically it might take 3 to 4 hours to fit. In the trials and development that we proceeded with, we got to the point where we were installing those within 20 to 30 minutes a piece, which is a fantastic installation saving. So this is what as you saw from Helen's slide, this is what the final room looked like. So you can see the ConFloor modules in the middle, with the pipework modules running down the left-hand side, fan coil unit modules in and around, lighting modules that could have additional acoustic panels incorporated with them to take that from a BCO requirement to a well-compliant design. And then the several kits of parts for the ductwork that made the whole system efficient and quick and easy to put together. It also allowed Landsec to be flexible. So the ductwork was a click system. So basically they can be taken apart and fitted in a different configuration depending on clients' requirements for an actual fit out. So from a standardization point of view, the benefits we get is, from a manufacturing point of view, we can invest in more efficient processes and automation to streamline the manufacture. We can reduce waste, so during manufacture we'll reuse any offcuts from a pipework point of view, so that the actual amount that's going back into to get recycled is minimised. We can standardise the installation process across multiple projects. We get improved design efficiency because we're picking and placing parts that have already been designed from a Revit point of view. And overall, we can reduce our carbon footprints. Thank you very much.
Thank you. I'm going to pass over to our final speaker, which is Dave.
Thank you. Just let me know if you can see that.
That's perfect. Thanks, Dave.
Good. Okay. Good morning, all. My name's Dave Clow. I'm head of MMC for real estate in the UK for Turner & Townsend. Delighted to be presenting to you this morning alongside some great speakers previously. We've also worked on some of the projects. We worked on the Forge as well with the team, so there's some synergies across there. Bear with me, I'm just struggling to get onto the next slide. There we go. Apologies about that. My presentation is going to be slightly different, which we'll get onto after this slide. But first of all, I just want to say that we and I fully endorse the DfMA and sustainability benefits, particularly material efficiencies, labour efficiencies, where we can tap into a slightly different skill set, where we've got a dwindling construction workforce, and also a key point for us that improved gender equality between manufacturing industry and traditional construction. And I think when you take that and you add the digitally enabled design and manufacturing process, and which is critical to DfMA and sustainability to make it all work, and we look at considering the circular economy, you kind of have the 4 pillars of success. And there are great examples where the benefits are starting to be captured and measurable, as we've just heard in some of the earlier presentations. So there's some great work going on at the moment. So just looking at the current status, I think what we're looking at here is that in order to kind of realise the inherent benefits that that this process of design, manufacturing, assembly, and being digitally enabled and reaping those rewards. And particularly, I'm talking about the public sector here because there's so much demand there. I'm looking at it from a supply chain perspective now, that we need to create a mature supply chain that can sustainably and consistently deliver against that demand. So at the moment, we see that there is growing pressure, and there will be continued pressure to develop that supply chain to support the sector to deliver its ambitious spend profile over the next decade or so. And that public sector demand, just a nutshell here of some of the key programs that are coming out at the moment. We've got the hospital program, Hospital 2.0. We've got the Affordable Homes program. We've got the Prisons Alliance for New Prisons. We've got the existing DfE frameworks that are coming out, and CF25 coming out next year. And that's just a small amount. Those small amount total, £37.5 billion worth of public sector demand, which when you look at that over the next 10 years, in what is essentially a fairly immature supply chain in certain areas. So the challenges, I think, are we've seen, certainly on the MMC side, we've seen some failures across the struggling market. We've had COVID, we've had material shortages, we've had the price hikes and inflation, which are starting to level out. But once the prices have gone up, they've gone up. Skills shortages in terms of labour and in terms of actual skills themselves as our labour force gets older. And then again, we've also got the kind of government's ambition on the platform approach, which is ambition to look at cross-sector interoperability of components between their sectors, which is a challenge in itself. And also with the loss of pipeline and the investors at the moment, certainly with some of the developers we're talking to at the moment, there is a dwindling confidence in some of the MMC supplier and solutions that are out there in the market at the moment. So as an industry, we've spent a lot of time over the last few years studying and theorizing models for delivering MMC and DfMA approach. We all know from the DfMA overlay to the RIBA plan of works through to the platform rulebook, underpinned by the value toolkit. There's some fantastic work going on, and certainly they've been talked about on the presentations this morning. But I suppose the question is, how do we achieve the potential of the kind of what we're all talking about, the industrialization of the construction industry through its supply chain? So, how do we create that sustainable, efficient supply chain? And I wonder whether, going back to the government directive of is there the opportunity to look at interoperability between their sectors? Are there products that can go across prisons, can go across healthcare, can go across education? Because at the moment, that whole issue of investors' concern is around single supplier products, which will always be a risk in the market. So you go to one supplier, and that supplier goes bust or something happens, and you can't go somewhere else and get that same product to fit in. It can in small areas at the moment, but it's not en masse. So we are at the moment multiple manufacturers making single supplier products, and where we need to get to is multiple manufacturers making interoperable products. Why do we need to do that? We need to increase that strength of covenant for the investors. We also need multiple manufacturers producing the same product, gives confidence back into the supply chain, or into the supply. And I think an important thing also is keeping competition through production quality and efficiency rather than bespoke design. So again, big question, how is this sustained? I suppose this is the biggest question of all, is that at the moment, lots of programs, lots of portfolios, they will have agnostic solutions to an end product. They will work with kits of parts. They will work with contractors who will then develop their own systems to satisfy that particular requirement for a client. Is it time for the investors to guarantee the pipeline for the manufacturers and actually invest in their own design and spend some time designing some of their own products and taking it to a different stage, so that you are then, and this is not all the buildings, this may be components, but it may be that you're actually taking on board some of that design yourself, you're keeping the IP, and then what you're doing is actually tendering manufacturing rather than tender design and manufacturing. So again, big question for the market. Little success story. we were in competition through the NHS SBS framework. We won the northern tranche of the Youth Investment Fund Modular Building Programme. Costafine and Wright, the architects, won the southern tranche. We sat down with the client at the kickoff meeting and said, look, this is a nationwide programme. The architects need us, and we need the architects to get through the stage 3 stuff. So why don't we scrap the two tranches, north and south, and create a nationwide approach where we both work collaboratively together. We engage the supply chain very, very early. We standardize designs. We drive the cost down. We get certainty of pipeline, and we get certainty of cost. And that's indeed what we did. So we're at the moment rolling out 29 projects across the UK. They're only small, total value about 24 million in the youth sector. But what we've got now is a standard design that's rolled out across 29 sites with minor tweaks for individual sites. We've got a very, very good handle on the cost. We've driven it right down, and we've managed to batch geographically for the supply chain to actually deliver in their preferred areas. One step further we could have been maybe if all the suppliers in that framework had shared the same structural solution. We could have achieved a total approach to interoperability between those different sites. So that's just a little story of where that collaboration has worked really well, and the engagement with the supply chain. So that's the end of my presentation. Thanks for listening.
Thank you very much, Dave. I'm going to bring everyone back on. We're just waiting for Tim, and then I'll kick off the Q&A.
I'm here.
Perfect. I can't see you, but I'm hoping, can everyone else see Tim?
I can see Tim.
That's just me then. Not to worry. I'm going to start with a broader question. We've got quite a few questions coming in, but I'll give everyone a chance to submit more questions. What are the main barriers preventing firms from adopting prefabrication and DfMA strategies? And I guess more importantly, how do you think these barriers can be overcome? As an add-on question to this, someone else has asked, what are the added challenges preventing smaller organisations from adopting these technologies? Does anyone want to take a stab at that?
I'll go if you want, and it kind of picks up on the last slides really. I think early involvement is a barrier. You have to be involved early in order to gain the maximum benefits and design a building around a system rather than shoehorn a system into a building that's already been designed. That never works, and you've evaporated much of the benefits as well. I think there's always this thing about between pinning your flag to the wall in terms of a manufacturer against still a mindset that if we don't get 3 quotes and we haven't got competitive tension, we're not getting best value. And that's a real challenge as well. So, I mean, go back to what I think Dave was saying at the end, what we do want is multiple manufacturers that can make the same things. Millions of manufacturers can make a USB cable because the interfaces have been defined and standardized. And I think if we can kind of get to that point so that we can, components and solutions are interoperable and interchangeable, that's going to help in a long way. I have to say intellectual property is the enemy of adoption.
Yeah.
People think that they've spent loads of time and effort to develop something that's got IP baked into it, but actually it's probably a barrier to entry or a barrier to adoption. Actually, if we actually open sourced a lot more stuff, we'd get a lot further towards where we want to get to.
Totally agree. And I think to add to that is the inward investment required into the type of ecosystem of supply chain that we need to support the demand that we've got. There's going to be hundreds of new manufacturers coming into the marketplace. So, do they self-invest? Is it outward investment? Is it investment through the people that are driving the supply chain or driving the demand? That's a key one. I got a really difficult exam question before Christmas from a client where there was some American investors who, when you look at the profile of American companies, a lot of them do invest in MMC companies over there, but they don't necessarily do it in Europe because there's a concern about that, as I mentioned in one of the slides, about the strength of covenant. So it's a kind of the investment piece in the development and sustainability of those suppliers is really important, and where that comes from. Because at the end of the day, we know this. If you can't fill the factory with stuff the factory stops and it goes bust. So that the pipeline and continuing that pipeline is so critical, and the investment part of that is critical as well.
So, Graham, Helen,
I was just going to say that on what you're asking about the small businesses and how can they get involved, I think what everyone's saying in terms of the interoperability and sharing information, sharing IP, and that kind of thing, the more we can share within the industry, the easier it is for everyone to get on board. And that can be large companies, but also it can be the small companies, it can be small designers or small manufacturers. And so I think sharing information and spreading the word in a non-competitive environment is really important.
I think the early engagement is key. I sit on the BSIS, so the Building Services Association off-site committee, and sit around with our competitors and basically have discussions that we're all feeling the same issues and the same challenges of early involvement and design freeze and things like that. But what we are doing about that is basically we started off by actually we were all talking about the same thing. However, each individual company had their own phrase for that type of product, from a horizontal distribution to a flat module or a pipe module. So what we started doing from a BESA point of view is basically trying to align the language of the industry, so that actually we've got, this is what the industry again call a product. This is what we've always called in the past, and continue to develop it like that. And then we've been bringing out building bulletins over the last 6 to 9 months, and we've got that to continue going forward.
Perfect. Someone's asked, are the materials used for the construction of modules fire tested individually or as fully assembled units?
So if where we look at from an off-site module, basically we'll make sure that we understand fire strategy, and within that module we'll have that fixed and designed to be fixed to the structure in accordance with the fire requirements. So if that's supporting life safety cabling, obviously then between modules where it goes through the wall, we'll adopt a tested solution for that.
Okay. Sorry, Dave, you're on mute.
If this is also a question about general volumetric building, there has been lots of questions around the fire safety issues, around detailing, around interconnection between modules, where manufacturers have struggled to provide the right level of integration. I think most of them have had to kind of do or die. They've had to get that tested. They've had to resolve details of connectivity. They've had to resolve issues of fire protection. A lot of the guys that work in the MOD sector, where they've got to deal with the counter-terrorism measures, where they get everything tested, literally physically tested, they've had to go back to that regime. So I think it's cost the volumetric manufacturers quite a lot of cash and time to go back and get themselves back to where they were before. But again, in traditional construction, you've got a set of building regs that's got robust detailing. The hoops that we are made to jump through in the DfMA, MMC offsite world compared with traditional is significantly more rigorous. And I think once you've got that test done, it's a very competent detail then.
Moving from fire testing to cost, could the panelists please elaborate on the cost benefits of prefabrication? How does prefabrication maintain quality while achieving cost efficiency?
I've got a great example, actually.
Okay.
You'll think this is a bit weird with where I'm going, but there's a bit at the end that kind of meets it. My father-in-law is 87 years old, and he came to insure his car this year, and he's got a Honda hybrid, one of the new CR-V hybrids, and his insurance premium went from 800 quid to 5 grand. Okay. So dug a bit deeper. Anyway, got down to 3 grand, and the broker said, well, if you went for a Seat Ibiza, we could get you back to 800 quid. Now, the bottom line of that is that Seat Ibiza shares a platform and a shed load of components with VW, Seat, Audi, Volkswagen. and therefore the component parts of that car, if they need repairing or replacing, are significantly less than the one-off that he's driving, which is the new one at the moment. And I think that's one of the key things here, is that if you've got that interoperability across buildings and you can produce the same components en masse and continue to produce them the same, that's when you drive the cost down. And to tie in the factory piece in terms of the quality control, you've got that level of quality control. And I think that's probably the key to it.
I think the other thing is,
I'll go after you.
Oh, okay, thanks. I think it's an oft-used response, but it is about value and not just cost as well. So, I've worked on buildings, say, for example, community healthcare buildings of a good size, where they will generate a revenue of £500,000 a week. So if you can deliver that building through MMC or off-site manufacturing a week earlier, that's a significant element of value that's generated as well. So it goes back to what I was trying to present with the graph. When you do an assessment, it's got to be a holistic assessment, and unfortunately, sometimes, it's a more binary assessment that's undertaken, really. So we've just got to be a bit more nuanced in the way that we look and we assess solutions.
I think it's also looking at the other benefits as opposed to just the module being delivered. So we did a hospital project where we delivered risers. So there was no scaffolding required apart from to make the openings into the riser safe. And the main contractor at that point saved £180,000 in reduction in scaffolding costs.
And I think also looking at the building as a whole life cycle, because what we're saying is we're not going to just design for day one, but we're designing for components that can be reused on other buildings because of their standardization in the future. So if you can look at what the whole life cost is alongside other sustainability things like whole life carbon, for example, adding in that ability to have flexible buildings and adaptable buildings elongates a building's life, and therefore on a whole life basis you've effectively got a cheaper asset to run.
I think just a final point about the quality. We shouldn't, not to tar anybody with a brush, but we shouldn't assume that the quality will be better just because it's built in a factory. There have been lots of systematic failures of off-site manufactured volumetric or otherwise buildings that have been built, taken to site, and then found out that they were deficient in terms of their manufacturing.
No,
and so we need to make sure that we put the same level of robustness in terms of going to factories and making sure that we have a proper inspection test plan, and we're doing all the things that we would do if the works have been undertaken on site. And that's something that we certainly drive through, the need for that quality checking to the same degree as it would be otherwise.
Yeah. Helen, you talked a little bit on your presentation about some of the other benefits as well as cost, and one of them was well-being. Would you be happy to expand a bit more on that, talking about more of the human impact of implementing these strategies into your projects?
So I think there's sort of two aspects, or two main aspects. One of them is during construction and one of them is during operation of the building.
Yep.
I think during construction, if you can build quicker, then you have less time on site, and therefore there should be fewer incidents.
Yeah.
The idea of having, Graham shows some great slides of the way modules are being lifted using machinery, and there's a lot less impact on sort of people working, so construction becomes safer. So I think there's quite a lot of sort of well-being aspects. Also, you can open up the workforce, which I can't remember who mentioned it. I think it was Tim about, probably everyone mentioned it, about having less skilled construction workers, opening up the workforce and driving equality. And then when you get into operation, you've got a building where you've designed it in so much detail because you want to know what every component's doing. You know a lot more about your building, you know how it's going to work and operate. So we do a lot of simulations looking at energy efficiency, thermal comfort, daylighting, and you sort of know, you have a lot more data about the building, you know how it's going to perform. and that means that you can design for people to be more comfortable when they're there. I mean, the example that I showed with the forge will have a World Gold certification. So it's that idea of you can still use DfMA and use a broader range of sustainability or well-being goals and aspirations, and they don't prevent each other happening. They can actually work together to make a better building at the end of it.
Thank you very much. What are some of the practical strategies for integrating prefabrication and DfMA into construction projects? How can industry leaders promote a culture of innovation to drive sustainable change?
I think in many ways that's kind of what I was trying to allude to in our presentation. So re-engineering the process so that at the earliest possible opportunity, you are doing a proper assessment of the solutions that could be deployed, and just baking that into your day-to-day business as usual approach, really. Too often, I've seen too often, we kind of get it back to front. Sometimes we've gone there, we've programmed the job, we've worked out the logistics, and then go, oh, what MMC or offsite can we do? Whereas you have to do it first and foremost and go, well, what is the best solution to build this building from? And sometimes that will not be that will be traditional, and we have to, and that's not the wrong answer. But it's like, what's the best answer? And then everything you build, sequencing, your logistics, how you're going to do it, then has to flow from that, not the other way around. So it's a process thing and a behavioural thing to just re-engineer what we do and how we look at it.
Yeah, I think it's really important. I think they always say if you can design a building using a Cat 1 volumetric solution, then you can design it any way you like. Traditionally, 2D, 3D, whatever. I know it gives it some restrictions, but certainly taking that into account when you start and understanding what your end game is absolutely right. You just get it baked in. All of us will have been in situations, certainly from the architectural perspective, where somebody comes along with a design that's already got planning and says, can I volumize this? And you are literally shoehorning something back into a building. That inherently doesn't work. The cost goes through the roof. The client says MMC is rubbish because it's too expensive. I'm just going to build it traditionally. So you're missing the point completely. It's got to be done earlier.
I think it goes back to working out what the value drivers are for the project at the really early stages. And the client might have written down in their brief, we want it to be more efficient, really quick, whatever. But actually, they often don't write those things down because that's not what their end goal is. But if you can deliver those things to help some of their other value drivers at the same time, then you've kind of got, it helps lead you into what methods of construction is most appropriate. And every project will be different.
Case by case. What are the panel's experiences with existing buildings in DfMA?
So if you take the Birmingham New Street, we took basically we were trying to make it all white and airy as it is now, which meant taking out the existing spine, all the cabling, all the electrical distribution. So basically we had a 110 metre spine that was 8 metres wide and 2.5 metres tall, and right through the middle of the building. So trying to work with 1960s concrete and building drawings is quite a challenge, especially when you've got a tight timetable in a live station. So that it's about being adaptable and working out what the constraints are earlier on, what's right to do, what's not right to do, and where you're going to eliminate the tolerances that you're going to find. So we designed a bracket that could take 150 mil of tolerance, and then we did a complete cloud scan of the whole area, so we knew exactly where the columns that we were going to fix to were, and then manufactured the brackets very close to the site installation date to make sure we incorporated that. It's about understanding the environment you've got, and really defining what those interfaces are, but also know when it's not the right thing.
And I think also, like, we're designing buildings now that will be the refurbishments of the future. So we need to put in place measures now on new buildings or even in refurbishments of existing buildings, where when we get to this same problem 20, 30, 40 years in the future, we know what's in the building, we know how to deconstruct it, we know what can be reused and what needs to be recycled, or what can be reused as a component, what needs to be stripped back to its individual materials. And I guess it's that idea of building in circular economy principles of the buildings that we're building, so that we don't get the similar constraints that Graham's mentioned in future buildings.
But I think DfMA, to talk about a general principle, is that we are going to be looking at a lot more repurposing of existing buildings, and a lot of clients don't realise that there is actually the efficiency in terms of rationalising the way that you do a refit to speed it up and get. And I think, Graham, is what you're alluding to here, is that you can still create a building where you've used as much off-site componentry as you possibly can within a retrofit. It's no different. I mean, there are constraints, obviously, because you've got an existing shell that you're working with, but it doesn't mean you've got to go in there and do it traditionally. You can still improve working conditions. You can reduce working at height. You can do all sorts of things that still takes the benefit of that DfMA approach.
Herschel's asked, media coverage on MMC has come across quite negative, and we have to dig quite hard to find success stories. What are your top tips for clients who are averse to MMC and DfMA? You're smiling, so I'm going to say you're keen to answer.
Yeah, I think it has. I think it gets bad press. If you actually look at the statistics, I'm not going to try and quote them, so I can't remember what they are, but you look at the traditional building industry over the last 5 years, and you look at how many SMEs and large organisations have gone bust compared with what's happened in the MMC market. Let's use MMC rather than DfMA.
Yeah.
All the spotlight is put onto the MMC. It just seems to get tagged all the time with this kind of stigma. Oh, there's another one, gone into administration. But there are also, I think, what we've got to do is look at some of the great success stories, and a lot of people, a lot of projects where DfMA and MMC has been used extensively. I mean, for example, Tide Vision and the multi-story modular blocks that have been done in Croydon, and there's a couple more going up in London that T&T Linear, our cost guys in London, are dealing with. I mean, they are incredible stories. I mean, they've gone up 40% quicker than traditionally, and they're hitting a 7% over traditional construction cost point. But because they're not open market sales, which again somebody touched on earlier about the speed to market, that whole point of being able to get rental into the market very, very quickly using some of those solutions are incredibly effective. I mean, when I remember working with, don't want to drop names, working with Portakabin a few years ago, and they brought on a theatre and ward block of 4,500 square feet from start to finish in 3 months. So there are some incredible stories out there if you kind of dig a bit deeper. And at the moment, we do concentrate at the moment in the press. They grab hold of the negatives, the Ilka Homes and the LNGs and the crikey top hats at the moment are in the news. Caledonian, there's a number of them. So I think we've just got to try and influence our clients to actually and get out there and maybe it's up to us to start getting information back out into our clients about where the success stories are, rather than dealing with the negatives.
Yeah. Does anyone else have anything to add on that?
I think we've all worked on success stories. That's why we're here. We're here to talk about them. We want to share them, and I think we just need to keep on doing that.
Definitely.
And I think some of those success stories are quick to, or take a long time to develop, but then the actual media attention is quite quick. Whereas the negatives, the media like to draw it out.
They dwell.
Yeah. Project went well isn't particularly newsworthy, is it? So.
That is a fair point. We've had some great questions come in, and I'm sorry I'm not going to have time to get to them all, but that is definitely all we have time for today. I just want to say a huge thank you to our speakers for your time and expertise. It's been really great having you on and hearing your presentations. We do have another session this afternoon, which will be chaired by my colleague Daniel Gain, exploring construction optioneering through the use of AI. And then we have 2 more sessions tomorrow for Digital Building Week. This session and all our other sessions will be available on demand for 12 months via the same link that you joined by today. And there is also a survey at the end. So if you have time, please do send us your feedback. And thank you so much for watching. And thank you guys for speaking.
Thank you. Holly, just one last thing. I think I'll probably speak for all of us that if anyone's got any specific issues or any questions, just get in touch with us.
Yeah, absolutely.
Thank you.